Hey, what's up, y'all? We're doing this in one take. I'm right after class. Got a fourth period here. Gang squad out here.
Gang squad.
Yeah. Alright, we're going to divide polynomials. We literally just covered this. So, I know it's 9 days in the future, but... Alright, there's two types of ways to divide. You can either do long division or synthetic division. So I'm going to do it both ways. Check it out. Alright, let's set this up. We got an invisible layer. X minus 1, and then inside the house, you get x cubed minus x squared plus 3x plus 1. Alright, so now we got to figure out how to do this. You take this first term of the divisor, x, and you ask yourself, how many times does this go into x cubed? And you would say that it goes into it x squared times. How you got that is because x to the third over x is equal to x squared. So, now you multiply x minus 1, you multiply this whole thing by x squared. So this is going to be x cubed, then minus 1 times x squared, that's minus x squared. So now you subtract this whole thing. So x cubed minus x cubed, that's 0. Negative x squared minus negative x squared, that is also 0. So now we're going to have to bring stuff down. 3x and 1. The reason why we brought down both of these is because like we brought down 3x, let me get 3x, and we're not going to have anything for this 1 to subtract. So you'll see what I mean. How many times does x go into 3x? It goes into it 3 times. So we have plus 3 at the top. We get 3x minus 3. And we subtract down. 3x minus 3x is 0. 1 minus negative 3, that's 1 plus 3. It's going to be 4. So this, what you're left over with, is our remainder. So our answer is going to be x squared plus 3, and then plus your remainder on top of the fraction, and your divisor, so whatever we got here, this goes in the denominator. So this is going to be x minus 1. And this is our answer. So I'm going to do the same problem here, but using synthetic division. So remember, we're going to make a little timeout box. So here is what we put in the timeout box. If you have x minus c, you're going to put c in the timeout box. So for example, if we have x plus 2, you're putting negative 2 in the timeout box. If we have x minus 1 in this case, we're going to put 1 in the timeout box. Now you put the coefficients in order. So the coefficient for x cubed, that's going to be 1. And then the next one is minus 1. The next one here is 3. And the one after that is 1. So now you bring this down, you do 1. You always bring the first term down here. And now you're going to take the timeout box and you're going to multiply whatever number you have in here by this bottom number. So we're going to multiply this way. And we're going to put the answer to that in this next square. So this is going to be 1. And then we're going to add downwards here. So we're adding negative 1 plus 1 is equal to 0. Now we do the same thing. 1 times 0 is 0. Then 3 plus 0 is going to be 3. And last step, 1 times 3 is 3. 1 plus 3 is 4. So if you take a look at this, these are going to be the coefficients of our final answer. This first number is always going to be the coefficient of x to the power of whatever is 1 less than the degree of our polynomial. So the degree of our polynomial is 3. This is going to be the coefficient of x squared. And then we have plus 0x, then plus 3, plus this is going to be our remainder, 4 over x minus 1. So, as you can see, we got the same answer for both ways. Crazy. All right, so I got one more example. Got one more spicier example here. All right, we're going to do this both ways too. So let's go ahead and do it. Okay, we got something spicy here. We don't have an x to the fourth term, as you can see. We have x to the fifth, no x to the fourth, and we have x cubed. We don't have an x squared term either. So you have to be careful for that, and you have to make sure you put your placeholders on. And let's see what that looks like. So we'll have x squared minus 1 on the outside, and then on the inside we'll have 4x to the fifth plus 0 times x to the fourth. This is important. Plus 3 to the, sorry, not 3x, it's x cubed, plus 0x squared, remember this is important too, plus 2x minus 3. Yes, this is a ginormous polynomial. Now it's the same process. X squared, remember you just take the first term of the polynomial here, goes into 4x to the fifth, it goes into this, say, 4x to the third times. So now you multiply this by the divisor here. So you have 4x to the fifth, and then minus 4x to the third. And you're going to subtract down. So 4x to the fifth minus 4x to the fifth, that's 0. X to the third minus 4x to the third, that's 5x to the third. So the next thing we're going to do is bring anything down. So we're going to bring the 0x squared down. And we're also going to need to bring this 2x down as well. So let's do the next step. X squared goes into 5x cubed how many times? It goes into it 5x times. So we're going to have a plus 5x. Now we're going to multiply our divisor by 5x. So this will be 5x cubed. And then minus 5x. So you subtract and you go, this is 0. You get 2x minus negative 5x. That is 7x minus 3. And this is going to be your remainder because x squared doesn't go into 7x. We have too many x's in our divisor. So this is your remainder. So your answer is going to be 4x cubed plus 5x plus 7x minus 3 over x squared minus 1. I think that's right. Hopefully that's right. Is that what you got too?
Yeah.
Oh, okay. All right, well, let's see if we can do this by synthetic division, and let's see if we get the same answer somehow. I'm kind of skeptical, but we'll see, I guess. So, synthetic division. How you could do this, and I actually think this might not work, but theoretically you could do synthetic division for this because this bottom part here factors into x minus 1 and x plus 1. So theoretically you could do synthetic division, but I feel like it's not going to work because I don't think either one of these are actually factors of this top part. So I'm actually not going to do it. I didn't think about this beforehand, and I guess that we're just going to end it there. But you can just know that you can also do synthetic division if the denominator is something like, factorable into these parts and stuff. So if you have something like this in the denominator, you could just do synthetic division a whole bunch of times. All right, that's going to be it. So hopefully you had a good Thanksgiving, and hopefully you don't have COVID. So yeah, bye everyone.